Okay, welcome back to math class and welcome to 9-7. Today we're going to be talking about two special kinds of functions that we haven't learned about yet so far. The first one is called a step function. The reason it's called a step function is because when we graph it, it looks like a set of steps. Now, the notation we use when describing a step function looks like this. F of x, the function of x, equals the step function of x. It's a new symbol we haven't learned yet, but it looks like this. Basically what it means is that our y value can only ever equal whole numbers. No decimals, no fractions. So when we make a table of our values, suppose my function was y equals 2 times the step function of x, and I make a table of my values. What I'm going to do, we'll go 0, then we'll go 0.5, 1, 1.5, 2. When I plug 0 into this equation, I'm going to get y equals 2 times the step function of 0. Now 2 times 0 is just 0, and that's a whole number, so we're going to leave it at that. When I do 0.5 though, y equals 2 times 0.5. What's going to happen is, because I can't have a decimal place, basically, this number will only change, our y value will only change once we hit another whole number in our x values. When I plug 0.5 in, I'm actually still going to get 0 here. I know that's kind of confusing, but keep watching, I think you'll get the hang of it. When I plug in y equals 2 times the step value of 1, I'm going to get 2 times 1, which is 2. But if I try to plug in 1.5 into my step value, into my step equation, it's going to be the same as if I plugged the 1 in. I'm not going to acknowledge the decimal place. I'm still going to do 2. Once I hit 2, I'm going to do y equals 2 times 2, and that's 4. So basically I'm saying in a range from 0 until 1, I'm at 0. Once I hit 1, it turns into 2, until I make it to 2, and then it'll be 4. So our y value only changes at whole number increments. What that does to our graph is it means that now when I'm at 0, I'm at 0, right? 0.5, I'm still at 0. Once I get to 1, I'm at 2. So my graph is going all the way this way until I get to 1, because at 1, it becomes, my y value becomes 2. 1.1, 1.2, 1.3, 1.4, 1.5. It's all going to equal 2 until I get to my x value of 2. So I'm going to draw a line here until I get to 2. And then it's an open circle because it doesn't include 2, but it's all the numbers up until 2 will still be 2. Once I hit 2 though, my y value becomes 4. Now I don't have it here in this table, but if I was going to do 2.5, I'd still get 4. If I was going to do 2.6, I'd still get 4. 2.9, I'd still get 4, all the way up until I hit 3. So it'd be another line and then a circle at 3. You see how it's starting to look like steps going up. At 3, I would be at 6. And I would stay at 6 until I made it to 4. And it would keep going up like that in increments, being a flat line and then a step, and then a flat line and then a step up. So that's what a step function looks like. Basically, you find your whole numbers, and then it's all the numbers up until the next whole number. Doesn't include that one. We move up in our step. Hopefully that's pretty clear. If it's not, feel free to reach out and I'll try to explain it a little better. The next kind of function we're going to look at today is called an absolute value function. Hopefully you guys remember what absolute value is. Just as a quick review, absolute value is the distance of a number from 0. So absolute values are always positive. In other words, the absolute value of 5 equals 5, but the absolute value of -5 also equals 5. It's just the distance from 0, and it's always a positive number. Let's look at what that does when we try to graph a function with absolute value. Suppose, let's get my table back out. Suppose my function this time is y equals 2x plus 1, but the absolute value of 2x plus 1. Now looking at the equation 2x plus 1, I'm thinking in my head, oh, that's probably a linear function. But because it's the absolute value, I'm never going to have any negative numbers. So let's look at what that does to our graph. We'll plug in some numbers. Let's try -2, -1, 0, 1, 2. Okay. At -2, I'm going to get y equals 2 times -2 plus 1, but the absolute value of that. So 2 times -2 is -4 plus 1. -4 plus 1 is -3, but we're doing the absolute value. So the absolute value of -3 is just 3. If I plug in -1, I'm going to get y equals 2 times -1 plus 1, but it's the absolute value of all that. So I'm going to get y equals the absolute value of -2 plus 1, which is going to be the absolute value of -1, which is just 1. All right, let's plug 0 in. Y equals the absolute value of 2 times 0 plus 1. 2 times 0 is 0. So we're going to get the absolute value of 0 plus 1, which is the absolute value of 1, which is just 1. Okay? We plug 1 in. Y equals the absolute value of 2 times 1 plus 1. We're going to get it equals the absolute value of 2 plus 1, which is going to be 3. Last one, we'll plug our 2 in. Y equals 2 times 2 plus 1. It's the absolute value of all that. 2 times 2 is 4. plus 1, which is 5. Okay, so let's try plotting these points and see what shape we end up with in our graph. Okay, so our first point is -2 and 3. 1, 2, 3. Our next point is -1 and 1. Our next point is 0 and 1. Our next point is 1 and 3. And our next point is 2 and 5. Okay, so these points at first glance look a little bit all over the place, but what you'll find with an absolute value equation is that they should all make a V like this. They're going to intersect our x-axis, but they'll never have any negative values, because when we take the absolute value of something, it's always positive. Now we didn't find the vertex here because it looks like it was at 1/2 and we used whole numbers. But that's okay, because you should know that it just extends downward into a V and does not cross the x-axis. This is how you can tell you're doing your math right. When you do a step function, it's always going to look like a set of stairs going up. With the absolute value function, it should always be a V.